Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll illustrate the use of SolidCAM's automatic feature recognition on the machine mold base as shown here on our screen. The machining is performed on a 3-axis CNC machine. Now, before we actually start with the feature recognition operations, we first used a face mill to mill off the excess material on top using the face milling operation. In the operation itself, we used a 40 millimeter face mill, and in our technology, working hatch going back and forth on the part. Taking a quick look at the simulation using Solid Verify, you can see that the tool goes down, working back and forth in a hatch mode across the part itself. In our next operation, we'll be using the pocket recognition operation, which automatically recognizes all pocket areas in the model and performs their machining. If I were to open up the operation, you can see that in the geometry area, where the solid body was chosen, filtering out any diameter which is larger than 17 millimeters, and finding every single surface and through pocket, as shown over here, on the part itself, recognizing exactly where to work on the part itself. The depth is automatically taken from these surfaces over here. The tool that we'll be using will be a 20 millimeter end mill, and since we have open pockets on this particular part, if we go in technology, you can see that we have here open pockets. In the open pockets, we'll be using the option of use profile strategy and approach from outside. Taking a quick look at the simulation, you can see that the pockets are automatically being detected and machined, and it goes down to each one of them, including the slots and these large holes over here, going all the way down to its respective depth. And this is done automatically without me telling it which depth to go down to. In our next operation, we'll start with the drill recognition. In our first one of the operations of drill recognition, we'll be using a spot drill to do a center drill on each one of the holes. If I were to open up the operation itself, you can see that in our geometry, all the holes were chosen by their different groups as shown over here and their shapes, and every hole that was between 0 and 17 millimeters was chosen in those groups. The tool that I used was a 10 millimeter spot drill, and if we go into levels, we customize the depth by going into depth edit, and each one of these holes were customized to go down according to the diameter value every single one of those groups. For example, the first group, we have a diameter value of 6, second group 7.5, and so on and so forth, according to the diameter of each and every one of those groups. Taking a look at the simulation, you can see that a spot drill is being created according to the diameter of each and any one of those groups. We have ones that are larger and ones that are smaller according to the diameter of those particular holes. And this is done automatically within one operation. Now, the rest of the drill recognition operations are for each and every single one of those groups that we have to be drilled out with their respective diameter drill. For example, if I were to open up the next one over here, if we go into our geometry, we can see that the hole diameter was filtered out to be only 13.5 millimeters, and therefore we only have one group of those holes as shown over here, and the drill will be using obviously a 13.5 millimeter drill. The levels was taken automatically this time from the upper level and the drill depth from the model itself. Taking a quick look at the simulation in this particular operation, you can see that every single one of those holes was drilled out to its proper depth. As far as the rest of the operations go, all of these operations were done in the exact way that this operation was done, everyone using their prospective diameter needed for drilling out the part. If we take a look at the simulation on the entire part, you can see we first have our pocket recognition milling out every single pocket automatically within one operation. Then we have the spot drilling every single one of those holes according to their prospective depth and diameter. And then we go on to the rest of the operations, each one with their individually sized drill being recognized automatically within drill recognition. Now, what I'd like to do now is add another operation to remove the chamfers around the edges. So for that, I'll go into Add Milling Operation, and we have the option of Chamfer Recognition. I'll choose my geometry by just clicking on the part. I'll also do a filter that anything larger than 20 millimeters in diameter, do not choose that. I'll click on the part itself, and I'll accept it. The tool that I will be using will be a chamfer drill with a 6 millimeter diameter and a 90-degree angle. And in my levels, I'll just write down the chamfer depth that I want, say 0.5 millimeters. In my technology, I'll use a cutting diameter of the tool of 3 millimeters. And let's do save and calculate, and we'll run our simulation. If we go into Solid Verify, you'll note the tool will go down, create a chamfer automatically on those edges as shown over here, until it finishes the entire part. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.